Field practices, sampling design and census of marine communities. Sampling methods. Depth transect. A depth transect is a kind of transect conducted when depth and slope vary along a route. Before conducting a depth transect, it is necessary to plan a scuba dive activity in relation to 1. Maximal depth that you want to reach, also considering your scuba dive limits. 2. Physical characteristics of the site, such as water temperature, tides, current, water turbidity. To perform a depth transect, it is necessary to have a dive computer, a measuring tape, a compass and a dive slate. The measuring tape should be enough long to reach the established depth. When a depth transect is performed, first step is to fix the tape to the wallet's surface or nearby. During descending, it is necessary to stretch the tape along the cliff, faithfully following its profile. One scientific scuba diver will be ahead, stretching the tape, while the dive buddy will be immediately behind to help fix the tape to the substrate. A compass is used to maintain the direction. Scientific scuba operators would check their dive computer, to check the planned maximal depth. After reaching the planned depth, the two scientific scuba operators will begin their ascent, collecting data, and controlling their ascent rate. One of the two operators will be ahead. He will record data about habitats, species, and substrate, that will written on a dive slate. The operator will gather depth data placing his dive computer close to the substrate. It is also indispensable to record meters on the measuring tape, in order to have a correspondence between biodiversity data, depth, and profile of the considered site. The second operator should dive behind the first one, collecting data as his dive buddy. This double data collection will be useful to compare records later. It would be also possible to split tasks between the two dive operators. One could collect biodiversity data, the other could collect information about substrates. The last operator should also retrieve the measuring tape. Tasks should be assigned before starting descending. Avoid complex underwater communication, especially at maximal depth. This will be counterproductive and time-consuming. Everything should be planned before diving. Let's see some short videos taken during sampling activities. After fixing the free extremity of a measuring tape, start stretching the tape along the cliff. Turn towards open waters, and, using a compass, follow the same direction to stretch the tape. Avoid making loops with the tape. Your dive buddy will be behind you fixing the tape to the substrate. To fix the tape to the rock, you could use U-nails on vertical cliffs, and cobbles on horizontal substrates. Remember to tie the dive slate to your jacket. Take also a spare pencil. Question: why do scientific scuba operators collect data while they are ascending, and not while they are descending? Look at the example. Assume that you have to collect data each meter along a vertical cliff. Now, you are looking at your measuring tape. You can read 79 meters on the tape. At this point, place your dive computer close to the substrate, in correspondence to the point where the number 79 is indicated on the tape. Here, the depth is 22.6 meters. Beside the tape, and the dive computer, you have to record substrate and species. All the data should be written on your dive slate, where there is a table composed of at least 5 columns. Here, report meters on the tape, depth, substrate typology and zoobenthic and phytobenthic species. Exercise: fill out the table with information relative to the dive site represented in the scheme. Depth data are indicated in red, while meters on the measuring tape are indicated with a blue font. Once data were collected, it will be possible to determine the profile of the considered site with a simple calculation. Assume to do a section of the study area at level of your transect line. The black line in the scheme is the profile of this section. Line 1 is an imaginary line perpendicular to the surface. Consider the points indicated with an X. Notice that the distance from each X, to line 1, is variable. In order to obtain a profile, we have to know these distances, here indicated with D1 to D7. If we traced lines perpendicular to the distances D, and crossing the XS, we would delimit right triangles. Question: how calculate distance D6? Consider the central triangle, ABC. First, we will calculate distance, AC. Which is the length of the segment, AC? Which operation could you apply to obtain this value? The segment, AB, is the hypotenuse of the triangle, ABC, therefore, we will calculate the distance, AC, through the Pythagoras theorem. We have two data at point A and two at point B. We will read meters on the measuring tape, and depth on the dive computer. At point A, depth is 8.8 meters, while on the tape we can read 45 meters. At point B, depth is 8 meters, while, on the tape we can read 44 meters. Distance, BC, is given by the difference between the two depths. Distance AB is given by the difference between numbers that we read on the measuring tape. Now we will apply the Pythagoras theorem to calculate the distance AC. AC squared is given by AB square minus BC squared. Distance D6 is given by distance D5, previously calculated, plus distance, AC. Exercise: calculate distance D7 knowing that D6 is 1.3 meters, depth at point A is 9.2 meters, number on the tape is 46 meters. Depth at point B is 8.8 meters, while the number on the tape is 45. This is an example of spreadsheet, where it is possible to write down data from the measuring tape, and from the dive computer, as well as recorded species and substrate. For each transect, it is also recommended to transcribe general information about the dive spot, such as name of the site and direction of the transect. Furthermore, it is indispensable to report the sampling date. The column in blue, distance from the coast, shows values automatically calculated by the spreadsheet. This is an example of graphical display of a depth transect. Exercise: transcribe this table to a spreadsheet. Then, in column B, write a formula to calculate automatically the distance from the coast, for each point of the transect. At the end, realize a graph showing the morphological profile. Data collection along a transect could be done even by conducting video or photo surveys. Here, you'll find a comparison between data collected by visual census and by photo or video surveys. Also consider that visual census could be more precise, if carried out by the same operator, or by operators trained in a different way. Video surveys require a lot of time to be analyzed, however, they could be analyzed by more than one scientist, to reduce bias in the species determination. Summarizing, several data can be gathered from depth transects. As any other transect typology, a depth transect supplies 1. A list of recorded species belonging to Phytobenthos and Zoobenthos, as well as a list of fish swimming near the bottom. 2. A list of habitats, for example, Posidonia meadows, or Sibellaria reefs, or Corallogenous. Substrate typologies can be also recorded, such as presence of rocks, sand, boulders, cobbles. 3. Depth data will be useful to know the bathymetric distribution of the recorded species, habitats, and substrates. 4. The use of the measuring tape gives the possibility to collect data on a seabed profile. Information about biodiversity and physical characteristics of the explored area could be combined to obtain maps of distribution of benthic communities and a geomorphological profile of the considered site. When several transects are carried out along a site, it would be possible to collect enough data to know the distribution of habitats, species and kind of substrate of the entire area.